So in this video I'll be going over the factor theorem. I'll be going over what it actually is and how we can actually use it for some commonly asked questions. Just to note, I will not be going through factorising polynomials and cubic equations. That will be done in the next video. So in this video I'll be going through the remainder theorem. So if you get a remainder of 0 when you divide f of x by x minus a or ax minus b, then x minus a or ax minus b respectively will be a factor of f of x. So basically what this, if I just relate this in terms of numerical terms, if I took the number 24, now we know that a factor of 24 is 6, so if I was to do 6 divided by 24, then what I would end up with is 4, and as you can see my remainder is 0. So therefore that would show that 6 is a factor of 24. Now what this basically is relating the algebraic version of this, that if I was to divide any polynomial by a linear function of x, if the remainder was 0, then therefore that would be a factor. And likewise, and again, the numbers that we're substituting in is the value of x that makes this equal to 0. So it's worth making a note of that factor theorem, and what I'm going to do now is just go through a couple of examples of where we can put this into practice. So in this first example, what we're going to do is we're going to show that x plus 2 is a factor of x cubed plus 3x squared minus 10x minus 24. So what you'd be expected to do in this particular question is substituting. First find out what value we're going to substitute. So to make this bracket equal to 0, x needs to equal minus 2. So what I'm going to do is I'm going to substitute minus 2 into this function, which if I just write out just so that it makes clear sense as to what I'm doing, and if I substitute minus 2 for x, minus 10x, minus 2 minus 24, lo and behold it does equal 0, so therefore x plus 2 is a factor. Now one thing that examiners are really after is students actually writing down this to confirm that it is a factor. So it's kind of just going for that final step, putting the icing on the cake of just showing that because this equals 0, x plus 2 must be a factor. Now if I was to substitute another number in, so if I was to say so if the question asked is, let's go for x plus 1 a factor, then what I'd be expected to do then is substitute f of minus 1 into that expression. So I'd have minus 1 cubed plus 3 lots of minus 1 squared minus 10 lots of minus 1 minus 24, and lo and behold that would not give me a remainder of minus 12. So therefore, as this is not equal to 0, x plus 1 is not a factor. So again, it's always worth just adding that extra line just to prove what you're actually stating. So if I move on to another example, so this time we've got a more complex linear function that we're substituted in. So again, what value do I need to substitute in? Well, I'm going to substitute the value that makes this of x, that makes this bracket equal to 0. So in this case, it's going to be f of a half. So substituting a half into the polynomial, and substituting that in, we get 0. So therefore 2x minus 1 is a factor. And again, always write that down rather than just showing that it equals 0, because in some cases examiners now are looking for this statement to get your final mark. Now moving on to the last example. So here we've got what we call a reverse question. So this is where we kind of know what part of the answer is, and we need to work out what part of the question is. So in this case, the first thing to read is read the question carefully. So we've got x minus 2 is a factor. So what I draw from that is when you substitute x equals 2, this is going to equal 0. So what I've got is if I have f of 2 equals 2 lots of 2 cubed minus 7 lots of 2 squared plus 2 lots of k plus 20, that this is going to equal 0. So working this out, here we've got 2 cubed, which is 8, times 2 is 16, 7 times 4 is minus 28, plus 2k plus 20 equals 0. So what we've got is we've got minus 8 plus 2k equals 0. So we've got 2k equals minus 8, so k equals minus 4. So that's just a brief introduction about how we use the factor theorem to work out questions like this. The next stage is to factorize cubic equations. There are a couple of methods for teaching that, which will be the next stage, which in my next video I'll go through, and which the factor theorem does play quite a prominent position in that one. So it's worth understanding this fully before we move on to factorising polynomials.